Ganymede, a moon of colossal proportions, holds a unique place in our solar system. Discovered by the legendary Italian astronomer Galileo Galilei in 1610, it marked the first instance of a moon being observed orbiting a planet other than Earth. While Galileo's discovery was groundbreaking for its time, little did he know that Ganymede would one day emerge as a beacon of possibility in the search for extraterrestrial life. Today, armed with the advanced capabilities of modern telescopes, scientists are once again turning their attention to Ganymede, driven by the desire to unlock the enigmatic secrets hidden beneath its surface. With each observation and discovery, the quest to unveil the mysteries of this intriguing moon continues, fueling speculation and anticipation about what lies beneath its icy exterior. Today, let's dive into this mysterious moon and talk about some shocking discoveries NASA has made about Ganymede. Jupiter proudly hosts a grand total of 79 moons, among which Ganymede holds the esteemed third position, nestled among the Galilean moons, the four largest satellites encircling the gas giant. Joining Ganymede in this esteemed group are Io, Europa, and Callisto. What truly distinguishes Ganymede is its impressive size, boasting a diameter of 3,273 miles. To offer some perspective, this makes Ganymede's diameter 0.41 times that of Earth's and surpasses the previously considered largest moon, Titan, by 1.02 times. Initially, Ganymede was thought to be even larger than Mercury, owing to its thick atmosphere extending hundreds of miles into space. Despite possessing a volume 26% larger than Mercury, Ganymede does not boast as much mass. This discrepancy is primarily attributed to Ganymede's lower average density of 1.9 grams per centimeter cubed, GCM3, compared to Mercury's denser 5.4 g per cubic centimeter. These variations in density stem from differences in their respective compositions. Much like Europa, Ganymede boasts a formidable surface layer consisting of a thick sheet of water ice extending a staggering 93 miles deep. Beneath this icy facade lies a colossal ocean of liquid water, presenting a truly awe-inspiring spectacle. The sheer scale of Ganymede's subterranean ocean is nothing short of remarkable. In stark contrast to Mercury, which harbors minimal water and is abundant in dense metals, Ganymede's abundance of water contributes significantly to its lower average density. What sets Ganymede apart is the sheer magnitude of its subglacial ocean. Estimates suggest that this vast expanse of liquid water surpasses the combined volume of all the oceans and seas on Earth. With an estimated average depth of 62 miles, it is a staggering 10 times deeper than the deepest point in our terrestrial oceans. Ganymede's composition offers a glimpse into its makeup, revealing that it consists of approximately 50% rock, with the remaining portion comprising water and trace amounts of metals and other ices. This alignment with classical mythology, where Jupiter, or Zeus in Roman mythology, claimed Ganymede as a cupbearer for the gods, seems fitting, given Ganymede's significant water content orbiting Jupiter. Intriguingly, Ganymede also boasts an atmosphere containing oxygen. Despite its abundant water and oxygen atmosphere, the prospect of life on Ganymede faces certain challenges. One notable obstacle is the thinness of Ganymede's oxygen atmosphere, which is estimated to range between 0.2 and 1.2 micropascals. To put this into perspective, it's approximately 100 billion to 500 billion times less than Earth's atmospheric pressure at sea level. The thin oxygen atmosphere enveloping Ganymede renders it inhospitable for human respiration. While Earth has showcased the possibility of ecosystems thriving in lightless ocean depths, Ganymede presents unique challenges that may impede the development of life as we know it. The immense depth of Ganymede's ocean raises concerns, as the water at its bottom is likely subjected to tremendous pressure, potentially leading to its transformation into ice. Unlike life forms found in the deepest reaches of Earth's oceans, which can flourish near geothermal vents, the thick layer of ice separating Ganymede's core from its ocean renders such conditions unlikely on this moon. Europa, Ganymede's neighboring moon, has long been regarded as a better candidate for the potential existence of life. However, recent findings hinting at the possible salinity of Ganymede's ocean could revolutionize our understanding of its internal composition. Models suggest that a salty ocean may give rise to multiple layers separated by ice sheets. In this scenario, the innermost layer could conceivably come into contact with the rocky core, opening up intriguing possibilities for the presence of life. Beneath Ganymede's icy exterior lies a perplexing phenomenon. The Moon generates its own magnetic field. This revelation, unearthed in 1996 during the Galileo spacecraft's flybys, has left scientists grappling for a clear explanation. The presence of auroras in Ganymede's thin atmosphere serves as a significant indicator of its magnetic field. What adds to the intrigue is that, during an extended observation period by the Hubble Space Telescope, these auroras displayed less wobbling than anticipated. This behavior is believed to be a result of magnetic friction occurring within a salty water ocean beneath Ganymede's surface. A magnetic field plays a vital role for celestial bodies, offering protection from solar radiation, an essential factor for supporting life as we know it on Earth. While Ganymede's magnetic field doesn't provide complete shielding, existing within the formidable magnetic field and radiation belt of Jupiter exposes it to significant radiation levels. Ganymede's surface registers radiation levels of about 5.8 rem, a level that could pose severe health risks to humans within just 2 months. However, this exposure is comparatively lower than that experienced by its neighboring moons in closer orbits. The enigmatic nature of Ganymede's magnetic field adds to scientific intrigue, as traditional explanations, based on a hot molten core akin to Earth's, don't seem to fit. Despite its smaller size, Ganymede's core, based on its dimensions and composition, should have cooled into a solid mass over time, hindering the movement of electrons through convection and the generation of a magnetic field. Curiously, none of Jupiter's other moons exhibit a magnetic field, making Ganymede the sole moon in the entire solar system to possess this feature. The explanation for this phenomenon remains elusive, but scientists are delving into Ganymede's unique relationship with Jupiter and its neighboring moons, with a focus on a process known as tidal heating. Ganymede follows an elliptical orbit around Jupiter, completing approximately one orbit every 7 days. This eccentric orbit means that at certain points in its journey, Ganymede is closer to Jupiter than at others. When subjected to the powerful gravitational force of Jupiter, an object tends to stretch in the direction of that force, with its mass pulled towards Jupiter due to gravity. This rhythmic stretching and contracting of Ganymede generates heat through friction within its interior. This phenomenon, where tidal forces produce heat through friction, is known as tidal heating. On a broader scale, the cumulative effect of tidal heating plays a crucial role in maintaining Ganymede's internal warmth, potentially preventing its core from completely cooling and allowing for the existence of a liquid layer. This sustained internal warmth, induced by the gravitational interactions with Jupiter, may provide a plausible explanation for the unexpected presence of Ganymede's magnetic field. Adding to the intrigue, Ganymede participates in an orbital resonance known as a Laplace resonance with two of its fellow Galilean moons, Io and Europa. This intricate resonance is characterized by a precise mathematical relationship. For every one orbit completed by Ganymede around Jupiter, Europa completes exactly 2 orbits, and Io completes precisely 4 orbits. This meticulous configuration is not happenstance. Rather, it arises from the gravitational influences exerted by the moons on each other, as the entire system strives to conserve the momentum generated. This orbital resonance subjects Ganymede to continuous gravitational stresses, stemming from the gravitational pulls exerted by its neighboring moons. While the role of tidal heating in maintaining Ganymede's liquid core, and thus contributing to its magnetic field, remains a topic of uncertainty among scientists, this phenomenon could potentially elucidate the intriguing features observed on Ganymede's surface. The Moon's surface is marked by large dark regions covering approximately 1/3 of its surface and lighter regions constituting the remaining 2/3. By analyzing the number of impact craters in these areas, scientists have inferred that the dark regions are older, as evidenced by their higher crater density. In contrast, the lighter regions of Ganymede's surface display fewer craters but feature remarkably long ridges and grooves, some towering up to 2296 feet in height and stretching across vast distances. While the exact formation mechanism of these ridges remains a puzzle, one proposed explanation suggests that tidal forces may have stretched Ganymede's surface during a turbulent phase in its ancient history. If indeed caused by tidal forces, this same mechanism could have contributed to the warming of Ganymede's core and the preservation of its magnetic field. Regardless of the precise cause, Ganymede's magnetosphere has been instrumental in providing insights into the Moon's composition for scientists. Through the observation of areas where auroras manifest in Ganymede's atmosphere, scientists have effectively confirmed the existence of subsurface oceans without the need for direct surface exploration. Yet, mysteries persist around Ganymede, sparking anticipation for the Jupiter Icy Moon Explorer (JUICE) mission, which holds promise for shedding light on these lingering questions. However, the JUICE mission is not projected to reach Ganymede's orbit until at least December of 2034. Until then, our understanding of this massive moon and its unique characteristics remains limited, and we are left to speculate on what sets it apart from its neighboring moons. If you liked this video, remember to like and subscribe for more videos on the wonderful mysteries of space.